Okay, I'm sharing my screen.
Sure.
Very busy.
I want to just run through the differences between primary key and foreign key. This is the topic related to the last week's session. So this is probably an important interview question as well. So the primary key main purpose is to ensure each row in the table is uniquely identifiable and maintains data integrity within the table. So primary key is unique.
Unique, right? Yeah.
It's not null. There is only one primary key per table, right? The role of the primary key is it is a principal identifier for records in its parent table and serves as a reference point for foreign keys in other child tables. So the primary key in parent table is a foreign key in the child table. This is important to establish relationship between tables, right? When it comes to foreign key, it's a relationship builder. It allows duplicates and nulls. There, there may be multiple foreign keys in a table. Yeah, I think in short, that's the main difference between primary key and foreign key.
So we can
Right?
have like more than one foreign key for a table.
Yes.
Okay.
So yeah, we can have more than one foreign key. Let's say you have you have a child table and you want to establish the relationship between that child table and a parent table one and one more parent table two, then you can establish the relationship between two tables by using two foreign keys.
Right. Yeah.
And in the parent one table, there is a primary key. Parent two table, there is primary key. Those two primary keys will be foreign key in the child table. Right? Yeah. And we'll go back to this week's session. So this week's session is advanced SQL and database integrity. These are the topics we will be going over in this week's session. Subqueries, and then we'll talk about joins a little bit. I know we talked about joins in the previous session as well. We talk about some aggregation functions, minimum function, maximum function, average, and count. While aggregating, we touch on group by as well. Yeah. Then aggregation with having, we'll touch about having as well. Performance optimization, how to create an index to optimize the performance. We'll touch about this as well. And then rollback, we touch about rollback, how to roll back a transaction. Then some security related topics we will be touching on, which is preventing SQL injection, basically writing safe queries, right? And then we'll talk about rank, row number, and some of the functions. And then there are date time functions. We will touch upon JULIANDAY. We'll try to compute the age in number of days. So this is the agenda for today's session. So, so over here in the cell, we are creating a table employees table. Employee ID is primary key, name not null, department not null, department ID not null, integer, salary not null, date of birth not null. So
Text all of them.
yeah, and we are creating the table. After that, we are inserting data into the table. This is the data we are planning to insert. So let me run the cell. You can see the output in the interactive editor. Tables are created. Employees data is inserted in the table. You can see over here the table is created. Employees table is created. Employee ID is primary key. Name, department, department ID, salary and date of birth. You can see the data also over here.
All the column.
Right. Then comes to subqueries. Subqueries are nested queries.
It's like inside another query, right?
Yeah.
Okay.
Yeah. Subqueries are nested queries. So subqueries are to fetch results dynamically within another query. Common use cases include finding maximum, minimum, or aggregated values. So we have created employees table. So now I want to fetch highest paid employee in each department using the subquery. This is the ask. You can think about how can we do it.
We can
For
do like
probably 30 seconds. Yeah.
We can use select or from.
Right.
Yeah, select from the table employee, right? And we can use the column name we're looking for, right?
Right. So I will show you the program. This is our query.
Yeah.
So we have to fetch the employee whose salary is the highest within the department. Right. So select department ID, employee ID, salary from employees table, where salary is equals to the maximum salary, where the department ID is matching, right? So I will probably show the step-by-step execution, so you will get more understanding on how exactly this query is working. So first, pick one employee row. So it is picking Ava, HR. This is the first row, right?
Yeah.
And then, yeah, we are picking an employee row. Then first run the subquery using the department, right? So the department is 10, department ID of this record. So we are running the subquery first with the department ID 10 and finding the maximum salary within the department. So the maximum salary within the department is 90K, right?
And we return it in the salary. We return the max and the salary.
Yeah. I think we can do this. You can be in mute. I'll explain the concept, then we'll open up for question and answer.
Sure.
Does that sound good? Yeah. Since we are recording it. So Yeah, and then so the maximum salary is 90,000 for department 10. You can see over here for department 10, the maximum salary is 90,000. So first to run the subquery, identify the maximum salary, and then compare the record's salary with the maximum salary. If it is equal, then that record is picked. If it is not equal, that record is not picked. So if you see over here, Ava's salary is 70,000, but we have to pick the maximum salaried person within department 10. So the Ava's record is discarded. Only no record is picked. Right. So the maximum is 90,000. So it will be basically run for each row, one after other, and check if the salary is the maximum salary or not. If the salary is the maximum, it will keep the record. If the salary is not the maximum, then it will reject the record. Right. So the output will be printed for this data is this output. I'll run it and show. Let me. I think this is a little better. Yeah. So yeah, you can see over here. Department 10, 90,000 is the salary, and the employee ID is 2. Department 20, the record should be fetching is Emma, ID is 4, so employee ID is 4, salary is 75,000. For the third department, it is picking up 6th employee ID record, and 6th employee Mason has the highest salary, right? I hope this is clear now. Okay. Then joins. Joins allows us to retrieve data from multiple related tables. So we are creating one more table called projects and inserting a sample data to the projects table. And we are joining employees table with projects table through the departments field. So we have department field in the table projects, and also we have department field in the table employees. So, and then we join on the department field. So inner join retrieves records with matching values in both the tables, right? And left join is basically retrieves all the records from left table and matching records from the right. So this is left join, and then obviously you may know right join is retrieves all the records from right table and matching records from left table. Right. So I'll execute this cell to create a projects table. So projects table is created. We can inspect it in the DB. Projects table is created. And it has the data as well, right? And I'm executing this join query now. We are joining projects with employees. We are joining on the column department, and we are planning to pick up only the records whose project name is project A, right? So if you see, if you see the data, project A is associated with department HR. And if we go to HR department, only two records are there, Ava and No, and we retrieved those two records. Right? So that is about joins. That is about joins, and moving forward, aggregation functions. Minimum is to fetch the lowest salary in the department. Max function is to fetch the highest salary in the department. Count function is to get the count of employees within the department, right? So this is the query. We are doing group by department, and then getting the minimum salary, maximum salary for each department, and number of employees present in each department. So let me run this. Okay, the interactive is here. The aggregation, you can see the aggregation, minimum salary, maximum salary. This is the department ID. Number of employees in the department is 2. If you remember the data, we have 2 employees for each department, right? So it is printing minimum, maximum, and number of employees in the department along with the department ID. So moving forward, until this point, do you have any questions?
No, thank you. You can
Okay.
continue.
Okay. Now we'll talk about having. We are selecting department name, average salary from employees table. We are grouping by department. We are grouping by department and trying to get the average salary. But there is a condition. I don't want to fetch all the departments with average salary. I want to fetch only those departments whose average salary is greater than 70K, right? So I hope this is clear, but let me just run it. So it fetched finance and HR department because their average salary is greater than 70,000. We can go to this table. So finance and HR are picked because their average salary is greater than, what is the amount? 70,000. 70,000, right? The IT department is not picked because if you do the average of 60,000 and 75,000, it comes to exactly 70,000 or less than 70,000, right? So that's why this record is not picked. So this is the explanation for having. I have a question here. You can try to answer. Why can't we use where instead of having? Where is also for condition check. And with having also, we are trying to do a condition check. But why not where? Why only having here?
I was just about to ask you about we can use if we can use where here or not. So
okay. Any guesses? Why can't we use where? Even though it's wrong, that's fine. Just do a wild guess.
I mean,
Okay.
if we use where, it's gonna be we cannot use it, or we have the option to use it. In this case, no, we cannot use it.
Yeah, I'll reveal the answer.
Okay.
Okay, answer is revealed anyway. So if we are aggregating, right, we are using average here. This is an aggregating function, and we are grouping by department and trying to fetch the average. So we are aggregating here. When we are aggregating, we can't use where. So here is the explanation. Where filter rows before grouping. Having filters groups after aggregation. So having basically filter groups after aggregation. Where filters before grouping itself. So yeah, having is to filter the groups, I believe. Where is to filter before we apply grouping. So we can write here probably where, yeah, where a department is not null. Anyway, department is not null, but we can say department equals to let's say IT. I think we have IT. So now what will happen? Before grouping, we are applying where. It will fetch only the department with IT and then get the average salary. And then if the IT department's average salary is greater than 70,000, then it will give that IT record. So I think where is applied before group by. So hope this is clear. So that's about having. Then comes to indexing. Indexing in SQL creates a data structure that lets the database find rows faster, similar to book index. Let's say you have multiple records in your database, not 5 records or 10 records. Instead, let's say you have 1,000 records. And then if you are trying to query on a database which has 1,000 records, your query will take long time, right? In order to improvise the performance of your query, you can apply indexing. Indexing is like book index, right? In a book, we have, let's say you read 5 chapters, then you put the thread at 5th chapter. So when you want to continue, you can directly open the 5th chapter, right? So it's like a marking up. So similar way in databases, we can create indexes that helps us to fetch the data faster, basically speeds up to lookups, and joins are faster, filters are faster when we have indexes. But with the advantage of getting the data faster, there is a little bit of disadvantages as well, which is when you apply index, it will be an extra storage, and your inserting and updating queries will take time with indexing. Right? Your fetching will be improved, but your inserting and updating will take little more time now with indexing. So this is how we create an index. Create index if not exist on the table employees department ID column. So we are saying to create an index name is this one on the department ID column of employee table. So this is about index. I'll run the cell. So index is created. I tried checking if the index can be seen in the database. I couldn't find the way to see the index we created, but you can try exploring it a little bit further to see if you can really check the index in the database viewer. Okay, that's about the index. Then we'll talk about rollback. Let's say I'm in a situation I want to execute two queries. If one of the query gets failed or triggers an exception, I want to roll back the transaction of both the queries, right? If they are succeeding, both should succeed. If one is failed with an exception, I want to roll back the other one which got succeeded. So this is really required in real time. Sometimes the data is dependent. If you are inserting the data, you should execute the two queries. Um, so this is basically helpful in real time. So here I have two insert queries. I have try except block. If one of the queries gets failed, then control comes to exception block and we are rolling back the transaction. So this is the example of rolling back a transaction. We just call rollback on the connection, right? Let me run the cell. So not null constraint failed on the department, and it printed the error. It printed the error means it came to exception, and obviously rollback has happened before we print the exception, right? So if you want to inspect, you can see John, Jane may not be there in the DB. Yeah, you can see John or Jane in the DB. That means the rollback has happened. The data is not inserted, right? So that's about rollback. Moving on. So this region, I'll collapse it. Now, comes to security aspect of parameterized queries. So here is again a prediction exercise. Basically, parameterized queries prevent SQL injection. So here I have examples of 3 SQL select queries. You can check these 3 SQL select queries and tell me which of these options is the right way of doing parameterized query in order to prevent SQL injection.
Yeah, I think number 1 is more safe.
Correct. Do you mind explaining a bit further? Why do you see number 1 is safe?
Because I think the parameter we're gonna enter department ID is not included in the from the query itself, so separate.
Right. Exactly. You're right. So what may happen is if it is not parameterized, someone may pass in a different query itself for the department ID parameter, right? We are trying to execute the select query, and let's say for this department ID variable, someone is passing drop table query itself. Then what happens? There may be a chance that your table may be dropped, right? So in order to prevent it, if we parameterize it, this value will be taken as a string literal. It won't be taken as a SQL query. It will be taken as a string, and this value will be inserted in the department ID field as a string, right? Or an ID. Um, so that is the explanation. This is the same explanation here. See, for the example 1, where we parameterized the query, someone has to pass department ID as 1 or 1 equals to 1. This is not just department ID, this is some kind of a query, right? But when we parameterize it, this value will be inserted in the DB. This query will not be executed. This value will be inserted as a literal, so we are safe. But when it comes to this second approach, this query will be running as if it's like a different SQL query within the select query, right? So there may be chance of risk and it's not secure. So this is the explanation. And moving on, the rank function. Over here, we are trying to rank the employees department wise. We are trying to rank the employees, right? This is the query. We are saying rank over partition by department ID, order by descending order, right? And when I run it, so name, salary, department ID, rank is 1 within the department because it has the highest salary in the department 10. Ava, salary 70,000, rank is 2. Let's see. Okay, these are in the order actually. If we require, we can. If I change Mason's salary to 75,000, for example, Then the rank of Mason will become 2. Rank of Olivia will become 1. Because when I change it to 78,000, it's obviously less than 80,000. So the 80,000 will be ranked 1 and 75,000 will be ranked 2, right? This is how the rank function will work. JULIANDAY function. Over here, JULIANDAY of now minus JULIANDAY of date of birth as age in days from employees table, right? JULIANDAY, basically what it will do is JULIANDAY of now. It'll give the JULIANDAY number of the today's date, right? It'll give the JULIANDAY number of the today's date, and we are subtracting from the today's date Julian number with the date of birth Julian number, and then we get the age in number of days, right? If I run this one, so we are getting, for Ava, the age in days is 13109. For Nova, so the date of birth is 1990, March 1990. Day is 3, I think. Month is 12. Is it? Yeah, this is month. So days, 3 is month and 12 is day, right? 1990 March 12th. The age in days until today is 13109. For 1988, obviously the number should be greater than 13109 because 13109, Ava born in the year 1990, no born in the year 1988, right? So the number you can see here, it's 13601. For Ava, it's 13109. I hope this gives little understanding. Yeah, I think I'll stop there. Next week, our next week topic is, let me go. Our next week topic is advanced data visualization techniques. We'll meet the next Saturday. If you get some time in between, try to check out the concepts which are in the advanced data visualization techniques topic.
Sure. Thank you so much. Thank you.
Yeah, I'll stop the recording. We can go over questions if there are any questions.